to talk about nested virtualization and PCI pass-through. It's kind of a obscure, unusual use case that we have, and we wanted to share some experience with, why we're doing it, how to do it, if you need it, in the weird and unusual case you need to do that. So it's like, I heard you like virtual machines, so let's put virtual machines inside virtual machines so we can have more virtual machines, something like that. This is kind of a general overview, and this diagram looks exactly like a diagram that I drew, but I didn't draw this diagram, I found it on the internet. So you have like the host operating system, and then a virtual machine, and inside that virtual machine you run a hypervisor and virtual machines inside the virtual machine. And kind of the terminology for that is L0, L1, L2, or host, guest hypervisor, nested guest, right? Why on earth did we need to do something like that? In our use case, we needed to test virtualized environments. So we had two options. Option one, have a lot of physical servers and kind of find a way to automatically deploy physical servers so we can test virtualized environments, right? Or alternatively, find a way to deploy virtual machines and make it so that we can run hypervisors inside virtual machines, right? Without a huge performance overhead. Like it's actually surprising that it even works, but it actually works without a large performance overhead. It works pretty well, right? And so this is one reason, just to, instead of having physical servers, have a lot smaller number, cheaper environment in which we can test hundreds of hypervisors, right? And the other reason is easier automation, control through an API, etc. Right? So in a physical environment, it would be a lot harder to do that. So how to do that? So there are a few things here to consider. One is there is some underlying technology available in the server platform. There are several of these. One is called VTD, or also known as IOMMU. Also coupled with something called SRIOV, which is the kind of the single rule type virtualization of PCI or PCI Express. And these two together, so IOMMUs and SRIOV, give you the capability to take a PCI device and pass it to a virtual machine, right? So you could have, say, a network interface card, and the network interface card supports SRIOV, meaning you can tell the network interface card to present tens or hundreds of PCI devices, and you take individual of these devices and pass them to virtual machines. That's SRIOV and IOMMU. And the other technology in the underlying platform is something called VMCS shadowing. So VMCS shadowing, I think this diagram explains it fairly well. It's a performance optimization, which makes level 2 guests work almost as fast as level 1 guests, right? So without VMCS, what ends up happening is a lot of context switching back and forth for every VM exit in the guest, right? The way, similar to other to page table virtualization technology, the way this works is that for each layer 2 guest, you get a separate VMCS control structure in the hardware, in the CPU, right? So it kind of detects that it's a nested virtualization case, and in addition to VMCS structures for each level 1 virtual machine, you get VMCS structures for each level 2 virtual machine installed in the hardware, right? And that enables a level 2 guest to work as fast as a level 1 guest. Let's find that thing, yeah. So that's the VTD and VMCS shadow are kind of hardware requirements. There are some kernel parameters which is enabling IOMMU support. PCI real lock. What this is it tells the Linux kernel to reallocate all PCI resources. The reason you need that is that BIOS is not clever enough, meaning it doesn't allocate enough PCI resources. So if you have hundreds of VFs, the way BIOS allocates PCI resources, there is not enough resources, and the kernel knows how to allocate them better. There is a parameter for the KVM Intel kernel module, which is nested. It enables nested virtualization in KVM. And there's another parameter to enable shadow VMCS. Without that second parameter, it will work, but it's slower, right? It's a lot slower. Then, in terms of Pci Pass-Through, so this article kind of describes what that is and how it's used, how to configure it, and how it looks like. So you have kind of the hypervisors, and you could make nested virtualization and Pci Pass-Through work with just libvirt and KVM, right? But we want to make that work in the higher level system, right? So we want API control and multiple hypervisors and live migration and all that. So the way that works is in OpenNebula, you have PCI devices, and OpenNebula knows how to pass PCI devices to virtual machines. It's used, as far as I know, it's used for two different use cases. It's used for passing GPUs to, say, machine learning applications or AI applications. And it's also used in the network virtualization context. So for example, if you have like a virtual router, for the best performance, you may want to pass a part of the network interface card to that VM. OpenNebula knows how to allocate these resources. So the way you do it is you create many virtual functions in the network interface cards, and then when you instantiate a virtual machine, OpenNebula takes one of these and assigns it to the VM and passes it to the VM. In this case, it's taken this PCI device and passed it to virtual machine 18, and it's taken the other one and passed it to the other virtual machine, right? The other thing that happens in OpenNebula, so this is the virtual machine template. So when you create the virtual machine, what this is these three parameters describe the device type, meaning kind of the vendor and the model of the device. And OpenNebula uses this to find which device to pass to the VM, right? And this is the type of the device, so it could be a NIC or a generic device. Well, there was something else in there. Yeah, not here. There is to get OpenNebula to recognize the PCI device and pass it to a VM, you need to configure this configuration file in KVM probes. And the only thing you add in there is kind of a device filter. So by default, it doesn't want to pass any PCI devices, and you need to tell it this is the type of PCI devices I want to pass. Further, there was some functionality which we needed and wasn't available in upstream OpenNebula. So what we ended up doing is, oh, come on, I clicked here. What I ended up doing is another one of our kind of customizations or tweaks to OpenNebula. So a good thing for OpenNebula is that it's fairly easy to expand it. So if it lacks particular functionality, there are places like hooks, places where you can add that functionality, right? And we call our set of functionality like that, we call that tweaks. So we have kind of the IO threads and SCSI queues, and the one we use for network interface cards is this one. It's called VF host device to interface Python. And it's a Python script we drop in a kind of, we plug into OpenNebula. And what it does is, when a virtual machine is provisioned, it looks in the virtual machine libvirt.xml, looks for a pattern like this, and translates it to a pattern that looks like this. The reason we need that is to assign static MAC addresses to these virtual machines. So what we do is, for each VM in its OpenNebula configuration, we have these parameters here, like which is tweaks, VF max. These are the MAC addresses we want, and which means when the VM is instantiated, instead of automatically assigning MAC addresses for the particular host where it was started, it would assign static MAC addresses, the MAC addresses that you specified. And we needed the static MAC addresses for kind of because various Linux distributions, the MAC address is the way a lot of Linux distributions recognize the device, and if you change the MAC address, unless you do something special, it assigns a new name for the interface, and it's a mess. So every time you start the VM, you get a new set of interfaces, right? And yeah, and the other one is kind of more StorPool specific, right? The environments we deploy, we test, we want them to be identical every time. Like, we don't want things to change every time we deploy these environments. Yeah. So that's that. Any questions on that? On the PCI pass-through or nested virtualization stuff? Nope. Cool. So the shameless plug part, we are hiring people for OpenNebula stuff and other stuff, right? So there's a lot of, like this stuff, there is a lot of interesting work happening at StorPool, and if you're looking for interesting work, we have it. Okay. And the other thing I wanted to say is thank you for coming to this event. I think it kind of helps the community to come together every once in a while. I think the OpenNebula community in Bulgaria should come together more often, but you know, it's always kind of hard to organize these events. It's kind of an additional effort that someone needs to spend to organize them, right? So thank you guys, and yep.